All right, well, we made it here to the last chapter for this semester. We're going to talk about geocoding. Um, this is one of those topics that's kind of near and dear to my heart. It's one of those tasks that is tedious and boring and necessary. And when you go out and get your first GIS job, chances are in the first year someone's going to hand you a table of addresses and ask you to geocode them, which is why we cover it. This is one of those topics that really can drive you crazy. So we're going to talk about what geocoding is, go through some of the types of geocoding, how to address some common problems, where to get data, and then go a step through the process of doing the geocoding in ArcMap. So when we say geocoding, what do we mean? Well, it's basically we're creating points out of text. Okay, so we have a table of street addresses. We know where those addresses are when we have a street layer. So this is automating that process of creating those points from that address information. So let's kind of step through this. We may, there are many uses for it. Personally, I geocode 2 data sets every year: a data set of addresses of employers and how many employees they have, and I also geocode a data set of new housing unit building permits and where those are in relation to the built environment. So here are some examples of using this tool. We want to know where the technology businesses are. We're a hospital. We want to know where patients are coming from, so we can see if we can open a satellite clinic. Location determination for a retail store. There's hundreds of examples of uses for geocoding. So we start out with 2 basic pieces of information. We start out with our data table, text file, database, whatever, that has information in it. In this case, we have company names, their address, and the zip code. The second piece of information we need to have is the reference layer that we're going to use for the address geocoding. The street center lines, the zip code polygons, whatever whatever scale we're actually doing the geocoding on. So we're going to talk about 2 types of geocoding. We're going to talk about polygon and address geocoding. So the polygon geocoding is we are assigning those points to a polygon. So in the data table that we just looked at, one of the data items was the zip code. So this would create points at the zip code centroid, count the number of records in each polygon, and then you could symbolize that map based on the polygon information. So we have here our zip code of 15068, and as we run through those through the data table, it assigns the points to each zip code, and then we can join that output table to our map table, and especially join them to the zip codes, and then we can symbolize that map accordingly based on the zip codes. So the other type is street geocoding, or linear geocoding, and this is using street data and the attributes of the streets, such as the name and the address range, and what side of the street that address range is, to approximate a location along each street segment from the the address information in our data table. So an address is made up of several components. It's made up of a number, a street name, a street type, a street direction. You can have a unit number, the city or zip code, state, and depending on the scale and your desired accuracy, sometimes it might be good enough just to have the zip code. So the general flow chart is like this. We have our input addresses up there in the upper left. The software breaks the address down into its constituent parts, and then it runs that through and matches it against the street data. If it finds a match, then how good is that match? If it doesn't find a match, then it doesn't return a result. It can also return multiple candidates in a tie for the user to go in and determine which is the correct output. So it uses a rule-based approach to score the data. Starts with a score of 100, and it subtracts points for each mismatch. Say that 3 times fast. So the street names may not match. The street type may not be there. However, it finds mismatches. And then, so we're looking here in this example for 125 East Oak Street. So it found 4 candidates for Oak Street. The address range goes from, so there's basically 2 segments here, from 1 to 99 and from 101 to 199. So it finds the candidate that's identified in there, and then it determines which, it's an odd numbered address, so it's going to be in the odd numbered range on the left side of the street, approximately 25% along that street segment. That's something to keep in mind, that it doesn't actually find the actual parcel or building. It's estimating based on the range, the address range on each segment, and the length of the segment, approximately where along that segment it is. It may not be exactly on the parcel that you're interested in. So what kind of problems can we run into? And believe me, there are many. We might find different spellings, variations of street names, Fifth Avenue, Fifth Ave, and Fifth Ave. Sometimes streets will have a name and then a route number. We might have misspellings. We might have what are called vanity addresses, or place names. The White House. In my particular example of the employment data, I run into a couple actually, a few, such as the University of Utah, Hill Air Force Base, Salt Lake International Airport. I know where that is. You know where that is. The computer doesn't unless we tell it. Also trying to find intersections, Fifth Avenue and Craig Street. That's a perfectly legitimate address reference if you're giving someone directions. It doesn't work really well when you're geocoding. Sometimes we run into misidentified zip codes, or zip codes that really only exist for the Postal Service rather than a physical location. P.O. boxes obviously are an issue. One issue that I found with geocoding the building permits is if you, at least Esri used to have a composite a locator engine, and we'll get into that in just a minute, but it would look at street addresses first and then a couple others, and the default was always the zip code. And so I was going along doing these building permits, and I noticed a whole bunch of building permits downtown right on the new federal courthouse. And I thought, well, that's really weird. Well, it turned out that the centroid of that zip code landed right there on the courthouse, and all of those had just been assigned as last resort because the software couldn't find an appropriate match with any of the other processes. So just keep in mind, you're going to run into issues, and I'm going to plug here in a minute spending time with your data and understanding what it is. So we'll get to that right now. So a lot of your problems can be rectified by spending time ahead of your geocoding with your tabular data, understanding what it is, how it's built, how it's developed. If you're looking at just street addresses, the software is going to choke on unit numbers, apartment numbers, floor numbers, suite numbers. So spending time ahead of time cleaning that up is going to pay dividends at the end, so you don't have to go in and clean it up afterwards. Okay, making sure you have high quality data sets, your street layers, your parcel layers, your zip code layers. Make sure those are as up to date and as accurate as possible. Make sure you're using standard addresses. And then finally, using alias tables. So this is a way around that White House, University of Utah, Salt Lake International Airport issue. Ahead of time you build this table. If the address contains this street, it's this is the location, or if it contains this location, this is the street address that I want you to assign that point to. Okay, so here in our example for our assignment, we have Pittsburgh. So we have a university there, Carnegie Mellon University, and all of its different variations in spelling. So you build this table with all those different variations and the address. Then when you go in to do your geocoding, you reference this alias table as one of the inputs, and that'll help you clean up your geocoding as well. So where do we get this data? So here we are back to the Census Bureau and our Tiger files. This actually is not a bad way to go. It's uniform across jurisdictional lines. The street address formatting works with standard addresses. So it actually isn't bad. It's not the most up-to-date data layer, and it really can be approximate where those address points end up. So with the more recent Tiger data, it's also informed by what's called the MAF, or the Master Address File. This is the file that the Census Bureau keeps for the decennial census. So those are referenced together. The MAF itself is confidential, but the Tiger data is cleaned up using the information from the master address file, and so the positional accuracy is a lot better with the more recent versions of the Tiger line data. So you can also get zip code areas. The Census Bureau doesn't actually maintain the boundaries of the zip codes. They have what's called the zip code tabulation area. It's approximate. If you want the actual zip code boundaries, the U.S. Postal Service is the one that maintains those, and that is a layer that's also available. You can also get data from local jurisdictions or state jurisdictions. Here in Utah we have access to the AGRC, the Automated Geographic Reference Center, which is the state GIS data provider. They have a lot of great data when it comes to geocoding. They have created a layer of parcel address points so that your address geocoding can be matched to the actual parcel. So check that out as well. Cities can help out to So what are some of the advantages of these, of the local jurisdictional data? They're updated a lot more frequently, and often have better accuracy, but they may not be readily available for download. You may have to contact someone, and they're for that jurisdiction. In our case, for AGRC, it's statewide. But if you're doing something in the Cache Valley or in Wendover, that might be an issue where it's going to cross a jurisdictional boundary. The other source is obviously to go out and buy it, and there's going to be plenty of vendors out there who are willing to sell you geographic data. Sometimes you can get a student discount or an educational discount, but just know they pay a lot of money to make sure their data is up to date and good, and they're going to pass that cost on to the users. So as a last resort, you could buy the data. You can also do geocoding online. Using the ArcGIS online tools or Google, it's quick. It's usually free or inexpensive, but you do lose that privacy, and if you're using confidential data, this is an absolute no-no to do that, because by turning it over to an online company, you've lost that privacy control. So how do we go about doing geocoding? What are the steps? Okay, so the first step is to create an address locator. This is the piece that sits in between our data table and our street layer. Okay, this is the translation piece. So in Art Catalog, navigate to where you want to go, right click and select New, and one of the options is Address Locator. Okay, and it will start your dialog box. First thing you want to do is select the style. This is the framework on which your locator is going to be built, and it really is based on your data table and your reference layer. How precise, how detailed that data is. Usually I'll go with the if I'm doing geocoding locally, I'll go with the US address dual range, which gives me side of the street accuracy. So again, here's a couple of possibilities, and the dual range there is based on the lines. The address range is both sides of the street, and so the application is to find a house on a specific side of the street, or a job, an employer, or whatever you're geocoding. The single house version is actually matching the address to a point, and so this is where, if you need parcel level accuracy, this is where you would go. So when you're building your address locator, the first thing you choose is your reference layer, or the street layer that you're going to be geocoding to. And so you would select that in the dialog box, and then on the right hand side you see the dialog there. At the bottom there's the field map, and this is where you would make sure that the field name that the address locator needs for the reference. So, for example, the house number is the correct field name from your file, and that's in the right hand side. And you can adjust those if they come in wrong, and make sure you scroll down and make sure all of the fields are correct. Now, only the ones that are starred there with an asterisk are required for geocoding. The others are nice to haves, and if you don't have them in your data, that's okay. But make sure that the ones that are starred are actually the ones that are in your file. Okay, then you can set up some more issues here. You can adjust the fields. that you want to use, you can, over on the right hand side, you can adjust the sensitivity to things like spelling. You can set up, this is where you'd set up your alias table, place name alias table there on the right hand side. You can also identify what connectors, what are legitimate text connectors for things such as 4700 South and Redwood Road, what characters make up that and are legitimate. So over there on the right hand side, also at the bottom, are some check boxes for some additional fields. When I do that, I always check that box for X and Y coordinates. That way, once it's matched, I have that XY coordinate and I never have to touch that record again, because I'll have that location as a discrete location on the globe. Okay, so now that you've got your address locator set up, to do the geocoding, you go into your ArcMap, you add your street layer and your tabular data to your map. Right-click on the tabular data in the table of contents and select geocode addresses. That'll open up a dialog asking what locator you want to use. Once that's set up, you click Run, and you'll get a little dialog box like that on a little status box as it runs there on the right hand side, telling you how many of your records have matched and what percentage what percentage that portion of your data table represents. And then it'll tell you when it's finished. And then you can click on that rematch button to interactively rematch any unmatched addresses. So when you click that, you'll get a dialog box that looks like this, that has the records there in the top, and then information there in the bottom part of that window showing the possible matches that could be available for each record. This is where it can get really tedious, and the better you know an area, the easier this part is. The assignment is set in Pittsburgh, so you will need to use a little bit of Google Maps to locate some of the unmatched records. So that is address geocoding. As you can see, I wasn't kidding when I said it was tedious and therefore something that you might not want to do, but something that you had better know how to do if you go out and get a GIS job. So if you work through the tutorials, it'll help you with setting up the address locator, which seems to stump most people, as well as interactively rematching unmatched addresses. So the assignment is again set in Pittsburgh with a table of immigrant-run businesses, and so you'll be matching those and then symbolizing them according to the business type. So as always, if you run into issues, contact me via Canvas, and I'll see what I can do to address them.